Hey guys, welcome back and let's continue with the next part. So last two classes of cryptography, guys, we have understood and I explained you multiple different things about the cryptography, right? Today, again, we'll move and try to understand some more powerful concepts of cryptography. Uh, but before, guys, I go ahead, let me tell you one small thing here in the cryptography. Even though I show you in my first class also, okay, if you want uh, if your applications or website is working on HTTP, I show you guys in my first class, and if you use HTTP, every data your login and password go in clear text, and just within a click, just by using any of the packet capturing tool, anybody can break and hack your data and also change your data also. Okay, but if you want to make it security or want to secure that in the form that nobody can read your data, I can say nobody can understand your data, then you can convert to HTTPS, S means secure form. Okay, and to give some HTTP is a protocol for website. Okay, it's the same thing for file transfer. We have FTP protocol. For mailing, we have SMTP protocol and some more. Any protocol, if you want to make it secure, we can secure it. Okay, for this we need SSL or TLS, especially known as TLS. The kind of newer version you can think of, we need. Okay, if you use the TLS, then thing will be secure, right? But in TLS, it is not only about encryption. Okay, so understand TLS, you have to understand entire PKI infrastructure, public key infrastructure. Okay, and to understand the entire public key infrastructure, you should know what is symmetric key algorithms, what I explained in my last class. You should know what is hashing algorithms. You know what is MAC or message digest authentication kind of algorithm. We'll see this kind of algorithm or message authentication code kind of algorithm. Will That's again the part of today's class. And then you should know what is asymmetric algorithms. Okay, and then after knowing this concept, then you guys can set up the entire PKI, and then the actual TLS can be implemented. Okay, so that's what, guys, we are doing this journey, right? So for example, if you're using a website like say gmail.com, right? So they are using HTTPS behind the scene, you guys know. Okay, so it doesn't means only encryption gonna help us. Encryption alone doesn't gonna help you, right? For example, right now I'm capturing my packet with a WireShark that you guys know. Let me recapture my packet from the WireShark, that tool I already introduced in the first day. And if you're using the Gmail, right? So everything is purely encrypted. They start, this lock symbol they're using. I show you in the first day also. And here, if you use, for example, let me stop this packet capturing. If you use TLS, enter. Okay, and what you will see here, okay, in this example, what you see here, maybe somewhere here, if you can see, yeah, this part, right? So from my laptop, I'm connecting to Gmail, because I show you nowadays they mostly use IPv6 version. So this is IP of Gmail I show you, and this is IP of my laptop I show you my first day. Okay, what you are sending, let's say DAOE, your IP address 2005 is the Gmail IP address. What you are sending, and this you are sending that I want to do TLS, means I want to encrypts everything or want to do much more in the security. It is it is not about encrypt only. Okay, and these are the different things I supported. That is called different methods I support, or cipher suite I supported these names. Okay, so server reply, out of these, okay, out of these names, what you write here, I only support this particular name, right? So guys, my point here is very harder to understand this concept in today's class. But if you just focus on this particular line, okay, focus on this particular line. This line say, okay, this line say that Gmail reply you back and say if you want TLS, it means entire setup of security or the encryption. This called PKI. Okay, I am using AES128. Now you know at least what is AES128. A is a symmetric key encryption. I told you is one of the powerful powerful symmetric encryption, and they are using 128-bit key. Okay, but I also want to use SHA256. Okay, that is what? That is a hashing algorithm. So here they are using AES128 key in the Gmail. So 256 actually, not 128 in this example. 256 bit key. What is this? In my last class, I explained in very detail. In hash algorithm, they are supporting SHA256 algorithm. In Mac, they are supporting GCM for the Mac, GCM. Okay, and for asymmetric, okay, they're using TLS, and what are the further version of TLS 1.1? Maybe they're supporting part of GCM or maybe RSA and something like this, or EC, DSA, something. So my point, guys, here is, right, just by looking that your site is HTTPS, is pure secure, it is not only encryption. Okay, lots of components work together to set up the entire website or mail server or LDAP server or whatever an application is to be secure, maybe databases. Okay, and there are lots of different part and concept work together. Then your entire setup or infrastructure becomes secure. Public key I means is a normally full form is public key infrastructure, but it means the entire setup would be secure. Okay, be secure. So my point here is, if you want to just convert HTTP to HTTPS, okay, you can't directly jump to this game of HTTPS if you really want to understand every concept of it. Okay, otherwise, there are 2 or 3 commands I can run and my website will convert to HTTPS. Anybody can do it, but what is happening behind the scene, very rarely, lots of guys doesn't know what is happening behind the scene, right? So you will be some few one who will know every bit of it, what is happening. Okay, so to reach through this journey, okay, to make anything and everything secure in all the forms, okay, we have to complete this journey. Okay, this part we have completed already in my last class in very detail. Today, plan is to understand the concept of hash and what is MAC. Plus, some more concept also I'm going to take today about authentication part also. So what is authentication also I'm going to discuss today. So these are the topics I'm going to cover today in very detail. And a lot of use case also I'm going to talk about these concepts. Tomorrow, we will start asymmetric algorithms. Again, after knowing this concept, then very quickly, maybe tomorrow we might move to TLS and the PKI. And after having this concept, we can secure everything. So what guys I draw here, don't try to understand much. If you don't know anything about this, don't worry. This is my responsibility to cover every bit of these concepts. Okay, so let me start one by one this concept. First, I would like to start the concept called authentication, right? And after understanding authentication, we can keep on relating this term in multiple different areas also. Okay, so first let me start this topic, authentication. Even though in MAC also is the message is also authentication kind of code. Okay, but we'll discuss one by one. So let me start this topic first called authentication. What is authentication, right? So guys, there's a multiple way and use of this term called authentication, right? One of the simple thing is, if you open this website, Gmail, for example, they're asking you that log in here. And to finding somebody email ID is not big deal. Even though guys, if you just see my history, you can very quickly get my email ID. So finding somebody email ID is not big deal. Okay, so let's say you find my email ID, you type here and submit, and now you're claiming to Gmail that I am Vimal.next world. But Gmail say, I don't believe on you, right? This username, anybody can find it. Okay, just to prove yourself that this account belongs to you and data belongs to you of this account, you have to prove me, and for proof, you have to give the password. So guys, in this example, okay, password is the way you are proving your identity. Okay, so anything that belongs to you, okay, that you are the owner of it and you belong to you want to prove your ownership, I can say, you have to prove that this is your identity, this is what you are claiming, identity. Okay, so for this we have to use certain process. That's process called authentication. So with the help of authentication, we can prove that I am the owner of it and this is my identity. I'm claiming I am Vimal and I am Vimal. Okay, in this case, I am giving password for proving my identity. So to giving the password is called authentication. So we authenticate, or Gmail authenticated me with the help of password. But this is one simple example that you almost everybody might know. Okay, password is a way to authenticate yourself, but it's not always the true that we need password. One of the example of authentication may be from your mobile phone, you send a SMS or the WhatsApp to me. Okay, let's say the mobile number of this guy is 1, mobile number of this guy is 2. So to receive a SMS, okay, with some data. Okay, so how to come to know that this SMS come from 1? So obviously in the sender, they have in the sender name 1 or mobile number 1 come up. Okay, so when the SMS come up, whatever the message is written, okay, to check the identity that this message, let's say this is maybe coming from your some relatives, or maybe some from your parents. How can you know this text come from parent? Very simple, we check the phone number, that's all. Or maybe we have some database in the mobile phone, for example, maybe have some name pop-up come up, let's say it's coming from my father. Because this name come up, it means it's proved that this message is authenticated, is coming from authenticated source, is coming from parents or fathers. Same thing, you do a Zoom call, the name come up there. You do mobile call. Right now, you call to me or I call to you. My name, number pop up over there, and that prove that this call is coming from me, from Vimal. So everywhere we have different way to prove the identity in calling the call, doing mobile call or sending SMS or WhatsApp or email or Zoom call. In this case, password. Depend upon situation to situation, we have a different way to prove our identity or the ownership. That the data that I'm sending, okay, or I'm claiming, okay, both the cases. For example, SMS 1 is sending from, let's say, from your father, for example, okay, to you. So to prove that this data is coming from father, we have different way. Maybe mostly we use and check in the sender in the top page that this coming from somewhere. Okay, accordingly you take the action to prove that is coming from there. So to prove that this data is coming from the right and the genuine source, we use a different step here. To claim for some data also, we might use some other way to claim some data. This belongs to me. In this case, I am using password. Okay, otherwise tons of different way available, guys, to prove that your ownership, your identity, whatever claiming, whatever you are having coming from somewhere, to prove that it's coming from the right source. Okay, all those concepts come under the umbrella of authentications. Now you can think as there's lots of things. You think how you claim something, or how you know that something coming to is from the right source. This is called again authentication. Okay, So typically, this is some example of authentication I'm talking about now. Okay, if you want to authenticate, there's a multiple way. For example, in this case, in the Gmail, I use a password way for authentication. So here I'm using password as one way for authentication. Okay, so whichever way you use for authentication, in this case, I use password-based way or password-based password, not key, sorry, password-based method I use here for authenticating to the Gmail. Okay, who decide? Obviously, Gmail decide. Gmail decide I will only understand password to claim that your account. Okay, I only support password-based authentication. Okay, this is called password authentication. Okay, or in sending WhatsApp or maybe email or maybe mobile call, I only see the number coming in my mobile phone as a pop-up. Okay, when this number come up, this is the way normally we use as a normal user of mobile phones to claim or to understand this coming from the right source. Nobody else actually try to spoof and try to fool around us by sending some message from other names. Okay, this is called spoofing. So nobody's doing any spoofing here. Okay, so here we're using this way. So whatever way you use for authentication is called authenticator. So my way of authenticator is password based or mobile number checking ways or email ID checking way. Okay, so which type of authenticator, guys, you would like to use? That is a point. Depend upon situation to situation we can use. Typically, for the authentication purpose, okay, we have three different types of authenticators. Three different types of authenticators we have. Over spring will be a check, right? So three different kind of authenticators we have typically. Okay, who is authentication? Who will check your authentication? Kind of program, kind of functions. Password is way, checking the mobile number is one way. Okay, checking the email ID is one way. Okay, somebody SMS email come from somebody, you just check your email ID, right? That's all. Okay, email come from that source, this means your message with somebody, that person only. That is a one way we prove, right, that is coming from the right source. Accordingly, we take the actions, right? So typically there's three different types of authentication typically, right? One way of checking the authentication is with the help of keys. How? Encryption keys. So encryption keys is one of the way to check the authenticity. So encryption key is one of my authenticator who helped me to do authentication. How? I'll tell you in a minute. Other way to do the authentication with the help of hashing. That's a part of today's class. And other way to do the authentication is called message authentication code. This is what we use a lot in today's world. Okay, so there's three different way kind of authenticators we have to do the authentications. Okay, let me first explain you this part, because some of the part we already discussed about encryptions. And you guys know one thing, there's two different kind of encryptions we have. Okay, one is symmetric key encryption, one is asymmetric key encryption. This part we have done already. Okay, both the way or both the keys of symmetric key and asymmetric key we use for encryption. The encryption is a different concept. Okay, encryption means either your data is there in your hard disk or in the RAM data. This is called data at rest. Okay, or maybe your data is traveling between two systems over the network or internet. This is called data in transit. Okay, in both the cases, if you want, your data won't be readable or understandable by anybody, then you convert your data, your clear text data or plain text data into cipher. Okay, so conversion to, you guys know, is called encryption. Okay, so here, if this is a use case that nobody can see your data, okay, understand your data, this is the only point. Okay, here I'm not talking about any kind of interference or means nobody can delete or nobody can change your data. Okay, encryption won't help you in this way. Okay, if your data is encrypted, anybody can remove your data, they have the power. Okay, they can edit your data, they have the power. Okay, they can add something on this data, they have the power. Okay, so encryption won't help you in this way. Okay, they can remove, edit, add, cut, paste, anything they can do it. Okay, encryption only helping you in one way only, is to just encrypt, means make your data in cipher, means ununderstandable way, non-understandable way. That's what encryption will do for you. Okay, these things encryption will help you. How we can solve this issue that nobody can delete also, edit also, remove. There's a different point. We might discuss something about this. Okay, but encryption also is not also is the way we learn the encryption till now. Okay, I'm only talking about encryption. Encryption is not the authentication, right? So encryption doesn't help you. As a nature of encryption, doesn't help you. As a concept I'm talking about, doesn't help you for authentication. So if your data is encrypted, doesn't means you say Google, I'm encrypting my data. So you encrypt your data, doesn't matter, right? But they won't give access to your account. For giving the access, you need a password. If you give password, then only they give the authentication. I mean, they only then they do authentication, and after authentication only you can access your account. Okay, so encryption is a different concept. Authentication is a different concept. Okay, but if you want to do authentication, then we can use a key for the authentication. Okay, let me remove this term. I don't want you guys to confuse with this term. So with the help of key, we can do the authentication. How? I'll tell you in a minute. Okay, I'll tell you in a minute. Or you can use any of the key, maybe symmetric key or asymmetric key. You guys, asymmetric is very, very useful. We use a lot for the authentication purpose. Okay, you know, asymmetric key is public and private key. We'll discuss my tomorrow class about what public and private key is all about. Okay, so asymmetric key we can use for encryption purpose also, and asymmetric key we can use for authentication purpose also. Similarly, symmetric key we can use for encryption purpose also. I saw you already in my last classes how to encrypt and decrypt the data. And symmetric key we can use for authentication purpose also. So key concept we can use for both the purpose. Even some purpose also we can do. The same key we can use for some other purpose also. I'll show you in upcoming classes of what and how. Okay, one quick example for asymmetric is, anybody know about SSH key-based authentication? If you know, otherwise I'll tell you in my next class what are these. Just to give you the reference, this is also they also using key-based authentication behind this, and this for asymmetric. Okay, but don't worry, I'll explain you this point in my tomorrow class. So this again not the class for today. Okay, today right now I'm focusing first on this part. Okay, so if you want to do authentication, how can we do the authentication with the help of symmetric keys? Okay, then I'll show you how we can do the authentication and much more thing with the help of hashing, then from the Mac. Okay, but if you talk about the hashing is not only for the authentication, we can do much more thing. Even though guys, today's then the future world is all of blockchain, and entire core basis of the blockchain is depend on the hashing. So if you know the hashing concept correctly, lots of concept of the blockchain will be automatically will be solved, right? The lot of base concept of the blockchain, you know, your cryptocurrencies and NFTs and all the things is about blockchain, and blockchain's core concept of security come from hashing all. So today I'll give you a lot of information about hashing and then the Mac. So these are the guys plan for today. If you understand what I'm talking about right now and what I'm not talking about right now, doesn't matter. Every bit I'm going to explain you from very zero. Okay, so let me start the thing from very zero, step by step. So first plan is this part. Symmetric key we use for authentication. Then we take this topic hashing that can do multiple things, and then take this topic Mac. Okay, there's a plan for today. Okay, I'm going to use the same approach. Okay, I will explain the concepts, multiple use cases, and I'll also showing you multiple demos also. Okay, so I'm going to use symmetric keys what can you do with symmetric key? Okay, one thing that you can do with symmetric key is encryption. How? You guys know. Okay, and same, you can use symmetric key for authentication also. How? So idea very simple, nothing very new command going to come up, but idea very simple. Let's say from a computer or a mobile phone, I want to send something to B. Okay, something to B. Or maybe here in my A, I'll say that these are the some instructions. We have 1, 2, 3, 4, 5. These are few instructions. Okay, I want from A send to B. Okay, and based on these instructions or my data or my information, B will do something. Okay, maybe my instruction, maybe I'm asking these guys that I'm asking you to send some amount to me. Let's say some $1,000. Or maybe one of the point I'm going to say that this is the my some employee name. I want to reset the password to Red Hat, for example. I'm asking this in this instruction. Maybe I want to ask some military persons change their positions. It will be any instruction, like it's a critical data we can think about. Okay, in this case. Okay, and let's say this is the one person in my company where we take the instructions from always. Okay, or maybe the director or the executives or chief executive we have. When the instruction come to B, how B know that this instructions actually come from A? Okay, there's a possibility when this instruction is coming on the way, okay, maybe via networking or some person is taking the information physically in the paper, for example, okay, they might tamper the information. Okay, maybe here in this paper, right, initially here A write the account number, let's say 111. Okay, and this account number they're asking to transfer some $10,000, something like this. Okay, somebody over the internet or the network, they will see this data. Okay, and let's say data is coming and going clear text. Okay, and they what they do, okay, they read the data, plus at the same time they also change the account number, say 222, their own account, let's say hacker account number, they change it. Okay, and when they reach to B, B see that this data is coming from A. Okay, and it's coming from A, and the A is asking, let's say this is my company's chief executive officer, they're asking to transfer this amount to this number. Let's say B we made from the account department, finance department. So they have to obey what the executive is talking about, and they transfer the account here. But what happened, and behind the scene hacker might change the information. That's called they tamper this data. Okay, so point here is, okay, point here is there's two concepts gonna come up here. Okay, but right now I'm talking about the authentication purpose. After some time I'll talk about integrity also. What integrity we'll talk on in some time. Okay, but I not talk about authentication. Here, what is the use of authentication here is, if B is getting some data or the packet from A, how B know this data is actually come from A? Okay, because there's a possibility if you talk about the networking perspective also. Okay, this is his laptop number A, right? Let's say belongs to this laptop of A has IP address 1. This laptop B, account department have IP 2, and we have a network in between. But we have some way in the internet world where we have one hacker in between, hacker over here. And what hacker can do, hacker can do one more thing. Okay, the hacker can send the data over this network to B. Okay, and while sending, there's a way hacker can change their IP address. Or while sending the packet, in the packet they change in the IP header that this package not belongs to hacker. Let's say hacker IP is 2, but in the packet they change the IP address. Okay, and they say this packet is sent by and from the IP address 1. Even the hacker IP is 3, but they can change this IP address. This concept is called IP spoofing. Okay, they can do IP spoofing, very simple. There are tool available in the market. Very easily, anybody can do it. Okay, they change the IP address, and so B field, okay, the B field, this IP is coming from IP1. IP1 belong to my CEO, for example. Okay, CEO, and because they think it's coming from right source, coming from right source, So they will obey it and they will do this instruction, whatever is sent by A, IP1, but actually they're sent by some other source. The point here is, right, how we come to know, okay, in the especially in the networking world, how they come to know what are packet coming up in this packet, what are instructions coming up, right, is coming from the right source, okay, right source, okay. So here they have to do authentication. So they have to check the authenticity of this data. Okay, what are they are claiming? Okay, they have to check it. Okay, and how to check this authentication? One of the way to check the authentication is symmetric keys. Okay, and how? Either very simple. Okay, because you guys know symmetric key. Any plain text, if you encrypt into cipher, we need a key. And to decrypt also, we need the key to get a plain text. And same key we need, that you guys know. Key 1, if you're using here, so same key 1 you have to use. Okay, so this is what the encryption is. But same idea we can use without doing any changes for the authentication purpose also. How? Okay, what can we do? A initially and B initially. Okay, initially somehow by meeting physically. Okay, they create one single key. There's a key number A. Okay, key number A. They create this key and share this key to each other. Okay, physically, maybe in the pen drive or physical medium, they share this key to each other. It means A has this copy of key number A. Okay, or let me give a different name. I don't want to confuse with the term A because the system also A. So let's say the key may be my key. Okay, so A has the my key in his laptop. B also have my key in his or in her laptop with them. Now, idea is, okay, what they can use this with, what they can do with this key. One thing they can encrypt, that is one point, but same key they can use for authentication. How? There's no different command, same command they can use. Okay, so what they do, A will encrypt data. I'll show you very quickly this commands, okay, to you. So I already have guys running with one operating system here. Let me use the same operating system of my Linux somewhere on the cloud, or you can use your other laptop also to do these demos. Okay, so I'm using one system here. Okay, let's say this is the one official document I would like to share with some instructions that I have to transfer amount to this account number. Okay, this account number, and the amount that you transfer is some this many dollars. Okay, they write in this document, they buy and take care. This data we have. Now I want to set up the authentication part of it. Encryption, you know, authentication part. How can I set? So for this, we will first create a key. Okay, how to create a key, guys? You know. Okay, we can use encryption, and for encryption, I want to use AES, for example, 256. This is for symmetric encryption, and I'm going to encrypt this file. Okay, with this file from the key. Okay, which key you want to use? For example, you know, I show you this command already in my last class. This is the one key I want to use. Okay, so this key, guys, initially is not randomly I'm talking about here. Let's say this key initially both guys plan and they share this key to each other, that we are going to use 1 2 3 4 5 always. Okay, now what happens if they use this key? Okay, this key over here. So what the commands we have is encrypted. We use a key as an argument. I think its key is small, or maybe, you know, there's this one command we created in the last class, or maybe use this keyword. Moment. So one please. Mouse is not working. Sorry, this is encrypted. We have to give the input. Sorry, so for we have to run this command. Okay, this will convert it, right, in some form. this key is converted. Let me store in the output, let's say final secure dot txt. Okay, so this key we create this same command, guys, nothing new. Okay, but the interesting thing is, okay, this key is with both the guys A and B. Okay, one benefit they're getting from this key is this key they can use to log this file, they encrypt this file. After file encrypted, they can remove this document, for example, document removed. Okay, and now this data is at rest in my hard disk, secure. And transit also network is secure, nobody can see the data is encrypted. One benefit of getting it, but by setting up this command, this same command I showed in my last class, right, we also get the authentication. Let's say this file I'd mail or transfer to from my CEO laptop to my finance or accounts laptop. Okay, how they know this data is coming from the A laptop, not from the hacker system? Okay, in this case, hacker might also create this file. Everybody know this command, right? They also create this command. They can also create this file with their own data in this file. Okay, from this plain file to the secure file. But the one thing that hacker don't have this key. They don't have this secret key. Okay, or this kind of symmetric key. Okay, so what happened at the laptop number B? What they can do? Okay, they run the same command again. Let's say this command, guys, I'm running in my laptop B. Let's say this is laptop B. This is laptop A. Okay, then running in their laptop, same algorithm they're going to use. They're trying to decrypt from this file, whatever file they get in the mail, decrypt. And let's say because B know already the right key, so they put the right key to decrypt. So here, exec data come up. Key is right. That's what they're able to decrypt. And because we use the same key, what has we use as the encryption time. Okay, and only 2% have this key. One is my CEO, and one is I am from account department. Because we know we have this key shared between these two guys, and that is the reason sometimes this key is also known as shared key. Okay, so this key is sometimes also known as shared key. And we know this key is always shared between two entity or two different members or two different team. Okay, it means this command runs successfully. It means this document is coming from CEO only, laptop number A only. Okay, it's not coming from any other system. Let's say if coming from hacker. Okay, so hacker, only thing hacker doesn't know is the key. So what hacker might have done, they might create their own data as SHA256 with their own account number, with their own amount to transfer. This data hacker created, for example. And hacker again encrypt because they want to create the same illusion that this is the file is encrypted. So hacker will will encrypt their file to get the same illusion that is coming from the same laptop. Everything will be same. Okay, let's say it's the final H hacker file, but hacker doesn't know your real key. In this case, he might try with other keys. Okay, so again, this file created, and this file again sent to my let's say this hacker laptop, and they sent to the B computer. B again try to decrypt it. Okay, how? Same way, decrypt this file. Which file? What they got in the email address, this file from the hacker system. But what to make this thing more realistic, hacker use the same algorithm. Somehow say he found out the algorithm name. Okay, hacker also send the mail from the same email ID of my CEO, because there's a very simple way, guys. We can do a email spoofing also. Okay, we can send the mail from somebody genuine email ID. Hacker can change the IP address also. It's very simple again to do it. So all the IP spoofing, email spoofing, sometimes mobile number spoofing also is possible. I can send you message from other mobile number from my mobile. So everything is possible, but this won't be breakable. Okay, only thing that hackers doesn't know this key. They try to use their own key, but they don't know their own actual key. But in my system number, B. Okay, because this key is shared key, only two guys knows. Okay, so first they run this command and this command fail. Okay, they are not able to decrypt it. Okay, and this is not decrypted. That is a very quick proof that this file comes to you maybe from same IP, same email address, not sorry, but it is coming from a different guys and they don't know my key. Maybe somebody trying to spoof or try to somebody try to give the wrong information and try to prove the wrong identity. Okay, this is one quick proof. Okay. So my point, I think you guys understand what I'm talking about, right? So this is not the new command. This is exactly same command. It means same command we can use for two purposes. Okay, two purposes. One, to encrypt, decrypt. Same key concept I'm talking about, symmetric key. The same symmetric key we are using for authentication purpose also. If this command is not run successful in the decryption, means this file is not coming from the right authenticated source. Okay, this one proof. And second things that you can do with this command is, if they come from different right source, then this will be decrypted. So you are also achieving the encryption also. So my final conclusion here is, right, if you use symmetric key, we can use symmetric key for encryption, whatever you guys know. Same command, no difference, you can use for authentication purpose also. This is the kind of error you get if they are not authenticated. But only thing is, between two entity or two identity where you want to share the data here and there for the checking authentication purpose, you have to share some key. In this case, this kind of key is known as shared key, plus idea is same. And this is what guys you can do. So this is one way. Most of the places, an example, we use this kind of shared key. Even though when I talk about HTTP and HTTPS also in my next tomorrow class, okay, there's some area we are using this shared key. I'll tell you in detail when I talk about TLS in very detail. So we use this concept to authenticate some part of it. Encryption is different point. I'm talking about only authentication part of it. This is one of the example of the authentication. Okay, that's all. Okay, so that's what I want to tell you. Let's cover the next topic. That is the main topic for today's class: hash or the MAC. But let me start guys with the hash. Okay, with the hash also we can do authentication, but much more thing we can do with the hash as a concept. Okay, so yeah, this part is complete. Nothing new, is a same old command. Okay, it's a looking thing is like kind of a revision, but I want to tell you the one more aspect of this particular concept, right? This I cover already here.